All right, so this broadcast is started. So if I think about it, I'll either email him or jump on a call to ask him about, make sure I'm labeling the graphs properly. And maybe I'll ask him about that last line that you brought up, Monica, to make sure. I don't know if I should even ask him. I mean, I'm asking him so many details. I feel like I feel like I'm taking over his calls.
He likes it though, I have to say, and it's so funny how he does it. He tries to teach you things rather than just answering directly your question. It's annoying, but I understand why he does it. So,
what do you think? And I'm like, I have no idea.
yeah, exactly. I'm like, oh, I feel so bad. Just say something, and then defend it. I was like, oh gosh.
Or I'll try not to say anything. Hope the next person says something first. All right. Well, Larissa, you have no more questions or comments, or do you have some?
It sounds good. With the QQ plots, are you pulling it up in Excel? Because I can try and look it up and see if I can like switch the. Oh, I can kind of see if I can figure that out.
It's the Excel that was in the quantity. Was it in the quant? It was in the. Yeah, I believe the quantitative data. Something like that. One of those charts. Let me look.
Okay.
Yeah, the quantitative data something or other Excel spreadsheet. That's where I was just doing a copy of the actual graph that I made and then putting it inside the document.
I can try and see if I can figure it out and let you know if I find something.
Okay, and if not, I'm sure he'll confirm if that's how we're supposed to label it. But I think that's probably, I think it's going to be expected different on the vertical and normal, observed difference on the horizontal.
Okay.
And what it is on the other one? The other, for the histogram, I think the quantity maybe was up and down, and the difference in price is the other for the histogram. All right, that's what I'll probably put down. All right.
Okay, awesome. I don't think I have any other questions.
All right, great. I'll see you next time.
Okay, awesome. Thanks, guys.
Thank you.
All right, you guys ready for your quiz? One more thing, Monica.
Yeah.
Even though I wrote that little at the beginning, the recap on tests conducted, I did that not as really part of this describe the data. It's just a recap, and he actually said that we should talk about the, I'm pretty sure he said you can explain a little bit more about that lurking variable on the thing that you're doing. What is yours called?
The inferential data.
Inferential data. He said we talk about that a little bit more in the inferential data, but I'm just like putting it out there so that I can include the graphs of both, and then you can maybe talk a little bit more about that in inferential.
Okay.
But I don't know. Hopefully we do it right.
Yeah, I'm trying to watch the video, but it's like a lot of echo and. But I'm watching
it was a lot of echo.
Yeah, I'll watch it.
All right. So we have our quiz. Let's answer the first couple questions.
True and true.
True.
Oh, good. These first two are really easy.
Yeah.
Yes. All right, go ahead, Charity. You want to kick us off?
Yeah, sure. Given the linear regression equation y equals 2 plus 1.5x, what is the y-intercept?
All right, hold on, guys. I got to put this in there. Open. Okay. clear data. And then and this is for everyone, males and females. Whoops, yeah. All right, y-intercept, go ahead.
Okay, so for the y-intercept, it's 2.0.
Yep.
Wait, maybe I'm looking at the wrong thing. Y-intercept,
You put all the data into the inferential, the Excel spreadsheet already, right?
yeah.
Oh yeah, these
Not asking-
those two
It's just
questions.
focusing on the equation that they just gave us. This is the one that's stupid easy.
Okay, given the linear regression equation. Oh, it says math processing error. That's why I can't, it doesn't show me an equation again, just like
Oh.
last time.
Oh,
All right, let me refresh it. So I was like, where's she getting any data from? There's nothing here.
yeah.
All right, continue quiz. Wonder why my
Equal
computer
y-
does that.
I don't know. All of a sudden,
I mean,
it
it's a
wasn't
new
really
computer. No, I bought this partway through the semester. It's a nice, updated everything. All right. Well, so much for that. Yeah, now I see it.
Okay,
Hey, what is the y-intercept?
so it's 2.0.
Yep.
And then number 4, same equation. What is the slope? 1.5.
Good.
And then number 5, given the linear regression equation, y equals -3 plus 0.25x. What is the value of y when x equals 16? I got 1.
Yeah.
You just plug it in your calculator. Is that right?
Yeah.
Yep.
All right, let's do that. 0.25 times 16 equals.
4.
Yep, I get 1 too.
Okay. For the next 7 questions, use the data
Wait,
file.
it says round to 1 decimal, so should we do 1.0?
Yes.
Yeah, I guess you could do that. It usually just gets rid of the zeros, but
So 1.0?
yeah. Oh, okay. Hold on, I gotta put in the data into the quantitative thing.
Oh, this is
And you need to make sure, it says be sure to use the confidence data for the explanatory variable and the score as the response variable. So this is where you need to input it.
Yeah. So
so confidence is.
is variable X?
Wait, which one is the same to use for the explanatory?
So we have
It
to
says
swap the order.
Yeah.
You got it. You should swap the order when you do this.
Okay.
All right, guess I'll redo that. Good thing Kayleen's like reading the directions.
Well, and I did pre-take the test really fast. Oh, that's not the screen I want.
And clear my data again.
Okay, so this is what I got in my graph. You guys can tell me if you did similar.
All right, not quite there, but
You're fine. You're fine.
So it says, what is the shape of the scatter plot?
Yeah, I have the same thing. So I think it's like a hot dog.
I would.
sorry guys, I'm still
Such a weird.
cutting and
Say
pasting.
a hamburger? I don't know. A hot dog or a
Your
hamburger?
content.
You figure it can fit a line, and the R is a strong number. It's 0.728. So I feel like it's a hot.
Yeah, me too.
All right. Yeah, it looks like a hot dog to me.
Okay.
Let's go.
And then it helps out what the next question is.
Hot dog. Okay. Want me to take on 7 or
I'll go into-
whatever? All right, go
Question
ahead.
7. Based on the shape of the scatter plot you produced in the last question, what can you say about the appropriateness of using a simple linear regression to model these data? Simple linear regression is appropriate for this data because it did calculate a formula for me.
Mhm.
And when you put in the line, it does appear to fit the data.
So it is appropriate.
I would say yes, it is appropriate.
So there are, what, 141 observations? No, there's not. There's 142 minus 3.
Should be-
Wait, 1, 2, 3. There's
There's 100 and
41, 40, 39. Is it 139?
hold on, check real quick. Yeah,
I said count because I used an Excel equation to do it, and I got 139.
yeah, 139.
For which one?
Right.
For question 8, it's asked how many observations are in the data.
So how do you do that one?
I used the
It's just
what was it, buddy?
how many numbers you inputted, like how many.
So that means how many numbers? Like, but you only count one of the, like, only the X or the Y? Or I don't understand.
I would say yes because you figure it's independent and dependent. So the other one's dependent on what you observe.
Okay. So what you have to do is count how many are there?
Yes.
So it's 139?
That's what
Yes.
I got. Now you're making me nervous. Whether we should be counting both or just the one.
No, I think it's just the one.
Okay, because it is dependent on the other, right?
Yeah.
I'll submit first though. It's what we get.
Okay, so observations is the number of data that we have.
Okay.
All right, I can take a couple. The y-intercept. So Monica, did you get 139 for then number 8?
Yeah, yes, 139, thank you.
Great. Okay. Number 9, I have 18.690.
Yes,
Yes.
And then the slope, I have, where is it? Okay, the slope is 12.695.
yes.
And then the predicted value of y when x is 4. Do we have an equation here? Oh, yeah, because we have the slope.
Just
So,
put
yeah.
it into the, yeah.
So we just do y equals,
Well, you can just put it in where it
Just
says
put it
X.
into the Excel sheet.
we
Yeah,
can
just
put it
put-
into the Excel?
Yeah, if you go onto the chart where it says confidence and prediction intervals for regression response,
Uh-huh.
where it says X and there's a blue box underneath it, input your number into the blue box.
Oh, I didn't know you could do that. All right, so I just changed to 4.
Yeah, and then the predicted one is that next number.
Okay, so the predicted is 69.469.
In the book, it says D18, that's why I didn't understand. So it's G18.
Oh, I know. I had to look at it because it said it wrong.
Yeah, I was
too.
a little lost with that one. So, okay, I'm just
Yeah.
gonna write the answer.
69.469. So how did it come up with 6 to begin with?
What?
So you come up with 6 to begin with because it would find the next one, right? So in the next one, it's a scale of 1 to 6. So 6 would obviously be the highest. What you need to do, what you really should do is find the max value that was actually observed. And you could do that by calculating an Excel equation, but the max value was 6 observed data.
The max value was 6, and so automatically calculated that because that happened to be the max value. Is that what you're saying?
Okay, I don't understand.
Because we're on question 12, right?
We
Okay,
are
I'm gonna-
now, yeah.
Mhm.
Okay, so it says the confidence data resulted from students evaluating their confidence for each question on a scale 1 to 6. What is the maximum predicted value of y for these values of x? So you said to use the max function with the x's or the y? The x's.
X's. Because it's asking what would be the y. So you got to find the max value of x.
But you said that we can also infer it by watching 1 to 6, like that thing?
Well, the scale is 1 through 6. So you figure the max value that would be up a max of a 6. That is the highest that you could go.
Oh, yeah. I also, okay. So if I found this question, I just want to make sure. So if it says predicted the value of x for the values of y, then it would be the other way.
Yes.
Where do we find the max value of y? Is it the prediction interval, the 117.445?
No. In order to find the max value of y, there's two different ways. Well, essentially but here's where it gets tricky. So there's two different ways you can find a max value of y. First way would be to use a max function in Excel and find out what the highest score actually was in the response variable y area. Okay, so that's one way to do it. The second way to do it, which is the way they're asking, is the maximum predicted value. So in this case, they're, hey, I want you to use the equation. So because we found the max value of x to be 6, we should just put the number 6 in that x box under the confidence.
And then 94.859.
You got it. So I think that's what they're looking for.
Okay.
And again, I'll submit first just to make sure, because otherwise you would think if you do an Excel function and find the max value of y, it is 100%. It's a 100. So.
Oh.
But the predicted one, which is what they're asking for, based on the line in your equation that you do, would be a 94.859. Okay, we ready for question 13?
Yes.
So how many explanatory independent variables are present in simple linear regression? So it's just one? How many explanatory?
How many variables?
So this is not looking for the observations. It's just for the explanation. So it's only one. Am I right?
Yes.
I would say because it's independent, but I don't even really know what it means.
So how many responses?
What is
at the very beginning? Here it says x is the independent x, aka also known as the explanatory variable, and y is the dependent variable, also known as the response variable.
Okay, and there's only one x in there right now, but you can have more.
I hope not.
All right, and
well, you can't. Yeah.
well, it showed in one of those things that you expanded in the actual book. It showed how there could be lots and lots of x's and lots of y's, or something like that.
Yeah, it says at the end of the book.
Yes, but that looks very scary, and I'm glad we aren't going to touch it.
Great. So the next one should be y, or number 1 also.
Yeah.
And then 115.
And then question 15. A company in South Dakota manufactures hard hats used in the mining industry. They record measurements on all the hats they produce for quality control and planning purposes. The measurements they collect include the size, circumference of the hat, and length of the major and minor axis. Meaning the company wants to predict size of hat given the circumference. What is the response variable? So that's a dependent. Let me see.
So the circumference
So
is explanatory, and then the size.
The y. So that would be.
Okay. What do you guys think? I think it's A, but I don't know.
I think it's A.
I'll show you, because this is one of the homework problems. Give me just a second. Here's what the data looks like, just so you can see. Can you see it now?
Mm-hmm.
So here's what the data looks like, and what they end up having to do is they have you put the circumference in as your one variable, as your x variable, and it puts this y variable, the hat size. So you have circumference and that output.
So what is the size?
Is what they're trying to solve for.
So you put A, right?
But A.
Yeah.
A.
All right.
So the size of the hat, because it's variable, being the predicted.
I'm submitting really fast. And we have 100%.
Woohoo! Sweet.
All right.
Thank you.
Just making sure I didn't like put something in wrong. Hold on a second.
Did you already?
I hate that, you know.
Yeah, sometimes you'll do something that you thought you did right and then you don't get it, but yeah, okay, I got it.
I'm goodness to goodness. I clicked the wrong button.
I got one wrong. Question
Oh,
12. I wrote 6 and it's wrong. Why is that?
Question which?
12? Oh, to 3 decimals. What were the
Oh.
decimals? What 6 point?
94.859.
Sorry, again?
Value, because they were asking what the predicted value was. So the predicted value should have been 94.859.
The 6 is what you should have put in the blue box underneath the X.
Oh.
Our bad. We got a little confused right there. So
Okay, just give me a second. So the 6 is for the blue box.
Mm-hmm.
got it.
So then it's 94.859.
Yes.
Okay.
All right then. Anything else that we need to cover?
I think I'm good. I think my making inferences is due next week, or this coming week. So I will start on that on Monday.
Do I have any more assignments in this project? Like,
I think from here on out, we're just really putting input and helping people that need help. So.
okay, but I don't have another thing that you assigned me then?
No, because now that we have
No,
so many people in the group, I feel like, wow, we barely do anything now. So.
Fine. Now
Okay,
we added.
yeah, we just each had one thing to do.
Yeah, because we essentially assigned Braden and Larissa the PowerPoint, which originally, like Monica and I and everyone was going to kind of team up on. So.
Yeah. All right, well, that's good. I'm glad they're gonna help us out with that. Like,
In some ways, it works out really well, huh? So.
yeah, 'cause that's a hard job. So now we have 2 people on that. That's good. All right, Monica, did you figure it out?
Yes, I got it. I just have to input everything again. I'm gonna do it. I have a question. Let me see. Did you all finish the homework quiz or not yet?
I haven't done the homework quiz
I
From lesson 21?
I didn't do
I
it
did.
yet.